Okay, so for our last topic, quarter four, week 8, we're going to talk about compound probability. So there's a couple of terms I want to define first, and the first one is independent events. So there's two types of events, dependent and independent events. We are going to only focus on independent events this week. So these are events that are not affected by previous events. Typically, they are completely unrelated, like rolling a die and flipping a coin. Whatever I roll on the die is not affected by whatever I flip on my coin. Those are independent events. If I have a bag of marbles and I put the marble back after I picked one and I get a fresh new bag, that is also an independent event. So as a review, our second topic, and this would be from previous years, not this class, but the probability of an event happening is found by taking the number of ways it can happen and dividing it by the total number of outcomes. So the notation we use for probability is a capital P, and then we'll use a parentheses for what we want. So this week, when we have events, we're going to focus on compound events, which typically means two items. You can do more and the formula just continues. So when you have two independent events, the probability of A and B, these are two events happening. So A is event 1, like rolling a die, and B is event 2, like flipping a coin. We can find the total probability by calculating each separately and multiplying them together. So because these are fractions, probability is a fraction, we are going to review how to multiply fractions as well. So let's look at some examples. So on the first one, we flip a coin and then we roll a fair six-sided die. The coin lands heads up and the die shows an even number. So what we want is the probability of a heads up, and then we want an even number. So I'm going to think of those separately. So the probability to get it heads times the probability to get an even number. So on the probability to get a heads, how many ways can the heads happen? Well, on a coin, there's heads and tails. So there's one way to get a heads. Out of how many total choices? There's two. On a die, I want to think of what are my outcomes. We've got 1, 2, 3, 4, 5, 6. So how many ways are there to get an even number? So 2, 4, 6, that's 3 ways. Out of how many total? Well, there's 6. So it's always how many you want out of total for each. Now, we're going to multiply those together. So when you multiply, you go straight across. So 1 times 3 and 2 times 6. So 3 out of 12 is our probability. We know we can reduce those numbers, so both divide by 3. So 1 out of 4. So there's a 1/4 chance that this will happen all together, both events. Let's look at one that's a little more straightforward. So we've got a cooler. It contains 9 bottles of sports drink. There's 3 lemon lime. There's 3 orange. And then there are 3 fruit punch flavored. So if we randomly grab a bottle and then we put the bottle back, mix them up, and then pick a second bottle, what's the probability that we will get a lemon lime on our first bottle, and then they want us to get a fruit punch? So if I split those up, we've got the probability to get a lemon lime and the probability to get a fruit punch. So a lemon lime, we've got how many are there? So there's 3. I know we're only picking 1, but you want to know how many total are there to pick from. Out of how many total Gatorade bottles? Well, there's 9. Now, I'm going to keep one of those lemon limes, but then I am going to put it back in the cooler. So we start back with all 9 again. So the probability to get a fruit punch, well, how many are there? Well, there's 3 fruit punch. Out of how many total? 9. So once again, we can multiply straight across. So 3 times 3 is 9. 9 times 9 is 81. So if we reduce, both of these numbers divide by 9. So we get 1 out of 9. All right, let's look here. Number 3, a basket contains 5 apples and 6 peaches. So we randomly select a piece of fruit and then we return it to the basket. Then we want to pick another piece of fruit. What's the probability that both pieces of fruit are apples? So we want an apple and then an apple. So let's split those up. So how many ways are there to get an apple? Well, there's 5 out of how many total? We've got 11. Now I'm going to put that apple back. So I start with a fresh basket. So how many ways are there to get an apple? There's 5. Out of how many total? 11. So 5 times 5 and 11 times 11. Now, none of these numbers reduce, 5s and 11s, so this is our final probability. All right, let's look at number 4. You flip a coin twice. The first flip lands on tails, and the second flip lands on heads. So what's the probability that we'll get a tails, and then we want a heads? So probability of tails times the probability of heads. Now this one, I'm going to list it out because really if we have a coin, what are the choices? We've got heads and tails. So how many ways are there to get a tail? Well, we've only got one tail on a coin. Out of how many choices total? There's 2 choices. Times how many ways are there to get a heads? There's 1. Out of how many total choices are there? There's 2. So if we multiply straight across, we get 1, and 2 times 2 is 4. That's already reduced. So there's a 1/4 chance that you will flip a tails and then a heads. All right, let's look at the marbles. So we've got 4 red and 8 blue. So what are we picking? Well, it says the first marble is red and the second marble is blue. So if we split those up, let's talk about red. So how many ways can I pick a red marble? Well, there's 4. Out of how many total? Well, 8 plus 4 gives us 12 total. And blue, how many ways can I pick a blue? There's 8. Out of how many total? There's 12, because we did return it to the bag. So we can reduce before or we can reduce after. I'll just go ahead and wait. So 4 times 8 and 12 times 12. So 32 out of 144. We are going to try to reduce this. So I know both numbers divide by 2. And we can divide by 2 again. 8 out of 36. We can divide by 2 again. And I can divide by 2 again. 2 and 9 don't divide by the same number. So 2/9 is our reduced probability of both events happening. All right, let's try one more with the spinner. So a spinner has an equal chance of landing on each of its 8 numbered regions. So if we had 8 numbered regions, our spinner would kind of look like this. 1, 2, 3, 4. So on your practice, I have some that have pictures already, but if they don't, you can draw your own picture. And we spin twice. So what's the probability that the first one lands on a 2 And then the second spin lands on a 7. So probability of a 2 times probability of a 7. So how many ways can I get a 2? Well, there's only one of them. Out of how many total choices? There's 8. Then I'm going to spin again. How many ways can I get a 7? Well, there's 1. Out of how many total choices? There's 8. So if we multiply straight across, we get 1 out of 64, and that's already reduced. So it's not very likely, but it is possible.